Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material. The structure shown is a 6-membered ring containing one ring oxygen with 2 carbonyl groups. One is a lactone, ester C is equal to O, since the oxygen is in the ring, and one is a ketone C is equal to O. This is tetrahydro 2H pyran 2,5,6H dione glutaric anhydride or a related cyclic structure. More carefully, the ring has O in the ring, AC is equal to O adjacent to O, lactone, and another C is equal to O on the opposite side, ketone. This is dihydro 2H pyran 2,5,3H dione, glutaric anhydride is a 5-membered ring. This 6-membered version is glutaric anhydride analog. Actually, this is 1,3-dioxane 2-1. Re-examining, the structure is a 6-membered ring with one O in the ring, carbonyl at C2, lactone, and carbonyl at C5, ketone. This is tetrahydropyran 2,5-dione, a cyclic structure with one lactone and one ketone. Moving on to the next step. Reaction with Lyell-4. Lyell-4 reduces both the lactone and the ketone. The lactone is reduced to give a diol. The ring opens, the C is equal to O of the lactone becomes CH2O and the ring oxygen gives an O after workup. Actually, lactone reduction gives a primary alcohol and opens the ring, and the ketone gives a secondary alcohol. Specifically, reduction of the lactone gives ring opening. The ester oxygen becomes an O on the carbon that was the acyl carbon, giving primary CH2O, and the alkoxy oxygen becomes a free O. The ketone C is equal to O is reduced to CHO, secondary alcohol. Product AH2CH2CH or CH2CH2O. Let me think more carefully. The 6-membered ring, OC, is equal to O, CH2C, is equal to O, CH2CH2 ring closed back to O. So numbering O1, C2, is equal to O, C3H2, C4, is equal to O, C5H2, C6H2 back to O1. Lyell-4 reduces, C to lactone carbonyl the CO bond breaks, C2 becomes CH2O, primary alcohol, and O1 becomes a free hydroxyl on C6. C4 ketone C4 becomes CHO, secondary alcohol. Product A is equal to O CH2CH2CH or CH2CH2O 1,3,5 pentanetriol, specifically pentane 1,3,5 triol. Moving on to the next step. Count of groups in A. Pentane 1,3,5 triol has 3 hydroxyl groups, 1 primary at C1, 1 secondary at C3, 1 primary at C5. And for the final step, reaction with AC2O. Acetic anhydride, AC2O, acetylates hydroxyl groups. Each mole of AC2O reacts with one O group, since AC2O reacts with ROH to give ROAC plus ACOH, consuming 1 mole AC2O per O. With 3 OH groups, X is equal to 3 moles of AC2O are consumed. Why other options fail? A. 1 and B. To undercount the OH groups. D. 4 would require 4 OH groups, but there are only 3. Only 3 OH groups are present in A, so X is equal to 3. Therefore, the correct answer is C. Therefore, the correct answer is option C.